but also the aspect of the economic aspects of the engineering as well as decision making. So decision making for engineering systems is called engineering economy. But this is a short way you can define engineering economy. Um, you make decision for engineering systems, making decisions for engineering systems or engineering buildings or any engineering application. You evaluate the project, you look at it, you study everything about it, and you make decision for this kind of project. This is called engineering economy or engineering economics. This definition may seem restricted to engineering projects and systems only. From the look of it, you think it is restricted to only engineering projects and engineering systems. But engineering economy is also the study of industrial economics. So you have an industry, all the finance, the economics that is going on in the industry is related to the engineering economics. And the economic and financial factors which influence the economy in the industry, all is regarded as engineering economics, engineering economy. So right from drawing the project, planning about how to run the project or how to invest, what kind of material you would buy to use for building the industry, how many people you will employ in the industry. Everything is related about with engineering economics. So you draw the project, you plan the project, you invest some money into it. Everything is about engineering economy. You manufacture you build the industry, you start manufacturing the products. Everything is related. Then you invest, you market your products. So you market your products, and then you get some profit. So you put all this into consideration when designing how to run your industry, and all this is known as engineering economy. So you can see how important this subject is to the industry, because just by the knowledge of your marketing or knowledge of manufacturing or knowledge of how to invest is not enough in designing engineering economy. So you have to put all this into consideration to effectively design how your industry will run. So engineering economy is all about decision making process. You start from understanding the problem. What is the problem at hand? What kind of thing is needed? For example, Jeddah need of a car, maybe Jeddah is in need of steel, and they don't have a steel industry. So now this is the problem. You define the objectives, you collect relevant information, you define the set of feasible alternatives, identify criteria for decision making, evaluate the alternatives and apply sensitivity analysis, and select the best alternative, implement the alternative and monitor the result. Everything here is all about decision making process in the engineering economy. So let's start just briefly looking at all these points. Understanding the problem, I already explained it. You have a problem, you look at it critically, you see what are the objectives of building this kind of industry or executing this kind of engineering project. And then you move ahead to collect relevant information about this project. Relevant information will involve, like, for example, if you want to build an industry for the manufacture of sulfuric acid, for example, then you look at you start stating the problem and the objectives of the industry. Like, we need to manufacture sulfuric acid in order to supply this acid to industries, and so on and so forth. Then you collect relevant information. You start saying, okay, only one industry is in Saudi Arabia that produces this kind of sulfuric acid, and this industry maybe is in Riyadh, for example, and these are the number of demands from Jeddah region alone for sulfuric acid. And for this reason, we need to bring sulfuric acid because there is a huge demand and the cost of transportation of sulfuric acid from Riyadh is high. And so if we bring it here, we're bringing it closer to the market, and so on and so forth. So this is the kind of relevant information that you collect to support your objectives. Then define the sets of feasible alternatives. So you look for alternatives. Alternative is simply we will look at the definition of alternative later in the class. But you look at alternative as something that replaces something. Yeah. So, for example, you have sulfuric acid, or you have you want to follow this kind of process in manufacturing your goods, or you want to do this kind of things in manufacturing your goods. You want to use this kind of material. So you look at other materials that can replace this kind of material. So you can compare between the two, which one is better for you, which one is can cost less, which one is more expensive, which one can withstand heat, and which one can withstand temperatures of Saudi Arabia, for example, and so on and so forth. So you look at all these kind of alternatives, which one will last longer, and so on and so forth. So this is what we mean by define sets of feasible alternatives. Identify the criteria for decision making. So whatever you are making, you need a decision in there when you are identifying your alternatives. So you look at the criteria that you will use to make a decision to choose one of the two alternatives you have. Evaluate the alternatives and apply sensitivity analysis. So what we mean by sensitivity analysis is, for example, you want to study the effect of this kind of tablet on the brain. Oh, okay, now let's not go that way. Sensitivity analysis is you test the market, or you test something and see how the market responds to this kind of condition. So an example of the brain tissue that I'm giving you. So you have a drug, you test the drug on the tissue and see how the drug responds to the medication. And then you take another drug and test it to the system and see how the brain responds to it. So you have different types of alternatives like this, different types of drugs, and you carry out this kind of analysis. We call them sensitivity analysis. And the feedback will give you the best drug, or the best scenario that you can apply um, for this kind of the best solution. I mean, so once you do the sensitivity analysis, you select the best alternative, and once you select the best alternative, you implement the alternative and monitor the result and see how um, how efficient is your alternative to the industry. We will look at all these things in detail, and so that it will be clearer for you in the next slides. So, for example, you have a decision, you want to make a decision for the industry. For example, you have an industry that always rely on renting cars for your day-to-day activities. So you don't have enough money to buy a car, and you decide to rent cars for the staff, or for importing goods into the industry, or something for the hospital in the industry, clinic in the industry, or so on, or something like that. So you have you want to choose between these two, which car you want to lease, which car you want to hire or rent. So you have an option of either renting Mazda, or you have an option of renting Honda Accord. Now you want to analyze between these two cars, which one is cheaper, which one will last longer, and which one is better for the industry. Now you put your sets of conditions and you start making analysis. The first one is to understand the problem. You define the objectives, yeah? So the objectives will be, we need a car with a good mechanical stability for the industry, so that it can last long, and we don't have to always go to the mechanic if the car is broken, and so on and so forth. The car will not break easily. So this is the kind of objectives that you set. Collecting relevant information will mean you gather all technical as well as financial data for these two cars. So you say, okay, Mazda, technical data for Mazda for the cars will include fuel consumption, that is fuel economy, how many liters of gasoline it will, how many kilometers of you will drive with 1 liter, for example, between Honda and Mazda. Based on that, you say, okay, this one is better than this one, or this one is better than this one. In terms of financial data, okay, another technical data, you look at the spare parts, okay, which ones cost higher than which one. For example, maybe Honda will cost higher than Mazda, and so on and so forth. Financial data means maybe how much you use to buy this kind of spare parts, for example, or how much if you are consuming this kind of fuel, then it means it cost higher to you. Or maybe the money you use to rent this kind of car, the initial money you use to rent the car, or maybe the monthly amount of money that you need to in order to pay the dealer. Okay, so this is what we mean by gather all technical and financial data. So this is under the aspect of collecting relevant information about these two cars. Then the third one is define the sets of feasible alternatives. Now this is the point where you choose between Honda and Mazda, okay, based on this kind of criteria, based on which car has more mechanical stability, which car has better fuel economy, which car has cheaper spare parts, and so on and so forth. So you look at you try to compare between these two alternatives based on this kind of data we have. Okay. Now the fourth one is identify the criteria for decision making. So your criteria is you want minimum total cash outlay. So you want to take an alternative that will give you better mechanical stability as well as cheaper option for your industry. Now, after you do that, you identify the criteria. Now you select which alternative is the best. So in these slides, they choose Mazda, for example, but you can choose Honda, of course, based on your assessment of this criteria. So now is the time to select one of the best alternatives. Once you choose the alternative, now you make sensitivity analysis. Maybe you say, okay, are the employers happy? Are the employees, that is your staff, are they happy with the Mazda? If they are happy, then you see how maybe they come to work early. Is a kind of result you expect from them, or maybe you kind of monitor whether really this Mazda that you've chosen, whether it will it save a lot of money from the industry or not. Okay, so the role of an engineer in engineering economy is a lot. It starts from creating the project, designing the project, okay, down to evaluating the financial impacts, or maybe evaluating the profit, if you want to call it profit. So the role of an engineer in an industry is big. So okay, you are the one who designs the industry itself, or you design what kind of products you'll be manufacturing in the industry. Okay, you start from making this your technical drawing. I don't know what you call it in Saudi, maybe technical drawing or engineering drawing. You write, you create and design this kind of projects. That is engineering projects. Yeah. Then analysis. What kind of methods you will be using in the industry to produce your materials or your products. Then engineering safety. Um, is it safe to work in this kind of environment? What are the steps that we needed to make to improve the safety of our employees and the facility of the industry, so it doesn't burn, or so that there is no any life that will be lost in the industry. So all these kind of things are the work of an engineer, and they are included in an engineering economy. Yeah, because the safety materials that you will buy them, you will use money to buy them. The kind of production methods that you will choose method that will give you higher conversion, that it will give you more product at less cost. So all these kind of things it needs the knowledge of an engineer, and as well as you couple it with the knowledge of economics to effectively execute this kind of projects. Then environmental impacts. So you want to produce your materials or your products that have less environmental impacts. You look at a lot of cars now that people manufacture, a lot of industry and engines of cars. Yeah, and they try to design engines that produce less emission. So they try to look at the environment before designing their products or before implementing their work. So the next thing is market assessment. You access the market, you see whether your products will be sold, whether they will be accepted into the market or not. And the next part of the next task of an engineering economist is to evaluate, yeah, but this is part of engineering economy, is to evaluate what kind of profits are we expecting in the industry based on the methods we use to produce, based on the money we injected into the industry, and based on the money we inject into the industry, maybe will include production methods, how many what we call it, feedstock we use to make this kind of products and so on. Evaluating the timing of cash flow and the degree of financial risk. Some of the things you do in the industry, of course, they have some risk financially. So, for example, you invest a lot of money in buying feedstock. So, feedstock that are highly costly, with the expectation that this feedstock will produce better quality material. So since you are expecting something you are not really sure, means you are taking a risk, a financial risk. So you need to evaluate the degree of this kind of financial risk that you are taking. Now, evaluation of impact of whatever you are investing on financial statement and market value and stock price. All this kind of these terminologies, we'll look at it in the future as we move along with the course. So now talking about alternative, we spoke a lot about alternative here. That means we define of a set of feasible alternatives choose between Honda and Mazda. Now, what is an alternative? In the quiz or in the exams, these are the kind of things you'll be expecting. What is engineering economy? How you define it? Engineering economy involve industrial economics and other financial factors that influence the industry, true or false, or maybe which of this is not part of an engineering economy. Maybe they will say manufacturing and profit. Is it part of an engineering economy or not? You choose true or false for this. So these are the kind of things we expect if a multiple choice question will be asked in the quiz or in the exams. What are the kind of changes that are involved in decision-making process in an industry? And here maybe some of the points here. And now, what is an alternative? So an alternative is a solution to a given situation. So, for example, going to UJ, you have maybe you can either use your personal car, or you rent a car, or you go with your friend's car. So your friend's car or renting a car is an alternative to using your car when going to UG. So an alternative, maybe an alternative of iPhone is a Samsung phone. An alternative of Mazda is a Honda, just the way we look at it now. So alternatives in engineering considerations, they usually involve such items such as purchase cost. So the money you use to purchase something. Okay. For example, you have two feedstock. You are producing tomato paste in your industry, and you have an option of whether to buy a local tomato, or you have another option is buy the tomato imported from another country, for example. So of course, the amount of money you use to buy tomato that is imported from another country will be higher and the amount of money you will use to buy the local tomato, for example. So now the purchasing cost of the local tomato will be lower than the purchasing cost of the higher listing. So this is an alternative usually discussed in engineering economy. Anticipated useful life. That is how long it will take, how long the half-life of this kind of materials that you will use to fabricate your industry. Okay, does it last long or something like that? And also yearly maintenance assets. So most of the days people prefer using Toyota because the maintenance fee is lower than other cars, for example, Mercedes, and so on. So the annual maintenance and operating cost is what this is the kind of alternatives people used to think of when you're designing their system. Anticipated resale value, salvage value. So when you are selling an item, what is the resale value of this kind of item? Just like the way I said, Toyota and Honda, for example, what is the resale value of Toyota and what is the resale value of Honda if you are to sell it? So these are the kind of things economists in the industry they usually talk about when talking about alternative. Okay. Also interest rates. After all these facts and all the relevant estimates have been collected, an engineering economy analysis can be conducted to determine which is the best from an economic point of view. So once you gather all this kind of information about the purchase cost, anticipated useful for life, that is how long it will last, maintenance cost, and then resale value. Now it is time for an engineering economy to look at it and determine which is the best alternative from an economic point of view. And based on that, we choose Mazda, for example, at this point. Not necessarily Mazda. I said maybe this is someone's slide. Maybe Honda might be cheaper option. Maybe the Mazda is cheaper option. I don't know. So an alternative is a very important terminology that you use in engineering economy, and you have to really understand it because no engineering economy if there is no alternative that can be provided. So you always need to have an alternative for any material that you will be using in the industry. Then cash flows. Cash flows, the estimated inflows, that is the revenues, and outflows, that is cost of money, that are called cash flows. So you have cash always flowing in the industry. For example, you have any shop, for example, you have cash that is coming in, people are buying your goods, and then you have cash that is going out. That is the money you use for maintenance, the money you use for paying workers their salary and so on. So this is cash outflows. Inflows are revenues, that is the money that comes into the industry, and outflows, they are money that goes out of the industry. Okay, that is cost, revenues and cost. Okay. Another terminology that you'll be using in the engineering economy is the equivalence. For example, in English, you say equivalent terms are often used to transfer scales or units, for example. For example, 1,000 meters, you say it is 1 kilometer. So this is equivalent. 1,000 meters is equivalent to 1 kilometer, like equal to, equivalence, yeah? But in engineering economy, this is English definition or the English way of looking at it. But in engineering economy, when considered together and the time value of money, that is the time value of money and the interest rate, help develop the concept of engineering equivalence, which means that the different sums of money at different times will be equal in the in economic value. So in economy or engineering economy, what we are often referring to equivalence is, for example, you have 100 reals last year or 2 years ago, and today you have 150 reals. Now you say maybe the 150 reals today is equivalent to 100 reals 2 years ago because of inflation. That is the money, the amount of things you would buy now with 150 reals, you can buy them 2 years ago with 100 reals, maybe because these days now you have VAT, for example, you have inflations. things are more expensive than what you have before. So this is what what we call economic equivalence. $100 now is economically equivalent to $110 1 year before. If $100 is invested at the rate of 10% per annum. So if you invest this $100 2 years ago, maybe it is increasing. It is increasing, and now maybe you will have $150. So this is a chart showing you details about cash flow. We said cash flow is all about cash inflow, the money that comes into the industry and the money that goes out of the industry. For example, cash sales, you sell something, they give you cash. Sale of fixed assets, okay, maybe in the industry you have furniture, you have cars that maybe you need to sell them because they are old. You sell them and you get money into the industry. You sell your products, you get money into the industry. Interest of bank balance, you have money in the bank, you save like 100 years in the bank, and they will be adding annual interest rate. Tomorrow it will be like $102 instead of $100. So all these $2 now is an income into the industry. Grants, if a donor agency grants you something, they give you some money into your industry. Maybe the government decide to give you money into the industry. Loan from other banks. So you go to other banks and you take some loans. All these are cash or money that comes into the industry. Share capital investment. If another person decide to invest in your industry, that is to give some money into the industry. This is also a cash that comes into the industry. While cash outflows can be in form of salaries, you pay people salaries, you buy some supplies, maybe some books into the industry or some papers or some cars into the industry. Payment for fixed assets. So you have some assets in the industry and you pay for this. Tax, you pay government some tax. Interest loans, so you take interest from banks, and now every year you have to pay additional money as interest for these loans. So this is considered as cash that goes out from the industry. Repayment of loans, if you repay your loans, so this is also money that you pay back to the industry. That is money going out of the industry. So this is an example of forms in which money will come into the industry and in which money will go out of the industry. In cases where you have negative cash flow, that is cash that comes into the industry is less than the cash that goes out of the industry. Or maybe cash that goes out of the industry is more than the cash that comes into the industry. Therefore, in this scenario, you have negative cash flow. Positive cash flow is when the cash outflows is less than the cash inflows. Okay, so the money that goes out is less than the money that comes in. In this case, you have positive cash flow. So you will have more money or you will have more profit into the industry. And here you will have less profit, or maybe the industry will go bankrupt if it is not appropriately checked. So this is a diagram that you will call cash flow diagram. A cash flow diagram is a diagram, is a graphical representation of cash flows, that is both cash outflows and cash inflows with respect to time scaling is generally referred to this flow diagram or cash flow diagram. So you have a time scale maybe from 0 year, from the beginning to the 10th year, end of 10 years. Cash that comes into the industry is usually represented by an arrow up. Then cash that goes out of the industry is usually represented by an arrow down. Okay, so this is what we call cash inflow and cash outflows. Up arrows for inflow and down for outflows. Okay, so time value of money. $1 received today is worth more than $1 received tomorrow, because of today's dollar can be invested to earn interest income. So if you invest money today, the money you invest, the dollar that you invest, or the amount of money you invest today, more than the amount of money you will get in the future. For example, future money, is equal to present money plus profits that you gain from this kind of investment, or the interest that you will be getting if you put it in the bank or something like that. Okay. So the difference in value from the money today and the money in the future is called time value of money, time value of money, TVM. This is another potential question that can come up, maybe as an essay or maybe a multiple choice question. Yeah? What is time value of money, or difference between money today and money in the future is called time value of money, true or false, and so on and so forth. Okay, and this is another potential question. I don't know how to say the question, but maybe they might ask you $1 received today is more than $1 received tomorrow, true or false, or why, something like that. What is the definition, or what do you understand by cash flow diagram? Arrows pointing up in cash flow diagram represent what? These are other form of questions that you will ask. They will ask you what is negative cash flow, what is positive cash flow, or anyway, another way. A question can be twisted in any form. Okay, cash outflows, cash inflows, salaries are considered cash inflows, true or false. So these are the kind of things that you will be asked. What is equivalence? What is an alternative? Okay, so that is it, I guess, for today. Next class will start from interest. Okay, do you have any question so far? Okay, you're all welcome. If there is no any question, then I would say have a nice day, inshallah. I will see you on Wednesday. Okay, have a nice time, inshallah. Yeah, welcome.